Hi, this lesson is about the characteristics in the graph of the natural exponential function. And that function is stated as y equals e to the x. So to understand this graph, we need to know what e is. E is the base of this function, and e is considered to be an irrational number. Remember, an irrational number is a real number. It cannot be expressed as a fraction, but it is a decimal that doesn't end and does not repeat. So here I wrote that e is approximately equal to 2.71828 ... And that's because those digits go on and on forever in no particular pattern. Therefore, the graph of y equals e to the x has the same characteristics as all exponential functions where the base is greater than 0. And specifically, it will have the same shape as graphs where the base is greater than 1 because e is greater than 1. So let's look at how you would sketch the graph of e to the x. So I picked some values of x because x could be any number, because the domain of an exponential function is all real numbers. So if you plug in -2, e to the -2, and you would need a calculator to come up with these y values, is 0.135. E to the -1 is 0.368. Remember, anything to the 0 power is 1, so e to the 0 is 1. E to the first power is about 2.718. E squared is about 7.389, and e cubed is 20.086. So as x increases, you'll see that the y's get bigger much faster. So you'll see here on the graph how the values on the negative side here get very, very close to 0, but never quite touch that x-axis. But as you move through and the x's get larger, this gets larger. The y values get larger very quickly. And remember, there's a y-intercept right here at 0, 1. So as a reminder, because in the previous lesson we talked about domain, range, intercepts, and asymptotes, the domain of an exponential function is all real numbers. The range is from 0 to infinity, but not including 0. Your y-intercept is at 0, 1. Your horizontal asymptote is the x-axis, which is stated as y equal to 0, and the graph is increasing over all real numbers. All right, so since, as I mentioned before, since e is greater than 1, the function of y equals e to the x, and its graph has all of the same characteristics as y equal b to the x as long as your b is greater, where your b is greater than 0. In other words, they will always be increasing from left to right, and then the rest of the attributes would be about the same. So as a reminder, if your base is between 0 and 1, meaning it's positive, but it's a proper fraction, then the graph has all the same characteristics stated above, but the graph would be decreasing. That would be the only difference. It would be going down from left to right. Okay. So here we're given that we want to sketch the graph of y equal to negative e to the x, right? And remember, we just graphed this one above. That's the one there in the blue graph there. Is the graph of y equal negative e to the x a reflection about the x-axis or a reflection about the y-axis? So this is actually a reflection about the x-axis, because when you put a minus in front, it means that all of these y values that you see here will be the opposite sign. So your graph is basically a flip of this graph. So imagine flipping this over the x-axis, and so that's what your graph would look like. So therefore, almost all the characteristics stay the same, except for a couple. The domain is still all real numbers, But this time the range goes from negative infinity to 0, not 0 to infinity. Remember, you read range from bottom to top. So it goes from negative infinity all the way up to, and as it's getting closer and closer to the x-axis, the y value is getting closer to 0. In this case, it is decreasing from left to right, so it's decreasing over all real numbers. The intercept is also different because the graph flipped, so instead of 0, 1, it's now 0, negative 1, but the horizontal asymptote stays the same. It's the x-axis, which is stated as y equal to 0. All right, so notice that this next one is similar, but not the same. So we know what the graph of y equals e to the x is. That was the first one we did. But this time we want to sketch the graph of y equals e to the negative x. So this time the negative is in front of the variable, not in front of the base, the way it was in the previous example. Okay, so that means that all of your x's will be the opposite sign. So all these x's that I had here, so if you plug in negative 2, it turns into 2. So all the y values will be flipped. So you start from 20.086 down to 0.135. So it'll go backwards in terms of the y values. So when you sketch that, it should look like what you see here. This ends up being a reflection about the y-axis. And some of the characteristics will be the same, others change differently. Domain is still all real numbers. The range is from 0 to infinity. It's decreasing from left to right over all real numbers. I have a y-intercept at 0, 1, and a horizontal asymptote at y equal to 0. And so here's something to keep in mind, that e to the negative x can be rewritten as 1 over e to the x. But when you look at it from this perspective, 1 over e is a proper fraction, because remember e is about 2.7. So 1 over 2.7 is a number between 0 and 1. And I mentioned before in this lesson, as well as previous lessons, is that when your b is between 0 and 1, your graph is going to decrease from left to right. So that's exactly what we see here. This is decreasing from left to right, and it's going to have that same general shape of exponential functions. All right, so for this next example, you will need a calculator. So you're given that y is equal to 0.5 e to the x plus 1, and we need to use a calculator to evaluate the function at x equal to negative 2 and at pi. Okay, because e is an irrational number, and pi is also an irrational number, you are definitely going to need a calculator in order to evaluate this, and you're told to round to the thousands place. Thousands place is the third position to the right of the decimal. So when you plug in negative 2 into a calculator, you should have an e key somewhere in your calculator. Some other calculators will actually have e to the x there, so you'll be able to input the x value. But if you just have e, you might have to hit the e and then the little caret key, which means to the, and then you can input what you're putting in. So here we're putting in negative 2, but that has to get added to 1 because that's the definition here. So you'd be doing e to the negative 1, and that works out to be 0.184. And again, that's an approximate answer because we have rounded. And when you plug in pi, you should be using actual pi, don't round it. And there, you should see a key somewhere in your calculator that says pi. So it's 0.5 e to the pi plus 1. Make sure you put the pi plus 1 in parentheses the way I did here. And if you evaluate that, you get that it is approximately 31.451. So it's really important that you be comfortable with your calculator, especially before you take an exam. So I suggest that you always use the same calculator and make sure you have batteries for them when you're doing homework as well as when you take your exams. All right, so we're going to talk about shifting, just a good idea to remind ourselves of those rules that we learned in the past. So we need to describe the shift of this function. So I have y equals e to the x plus 2. Remember, y equals e to the x was the first graph we talked about in this lesson. And when I'm adding 2 to the function itself, that represents a vertical shift 2 units. All right, so it's a vertical shift up 2 units, which means that your asymptote will also shift. The asymptote is usually at, for y equals e to the x, the asymptote is at y equal to 0. So when you shift up 2 units, your asymptote is at y equal to 2. And my y-intercept for e to the x is usually at 0, 1. So that's what we talked about at the beginning. But this time when you plug in 0 in here, you'll get 1 plus 2. So my y-intercept is at 0, 3. This graph is increasing from left to right over all real numbers. My domain is still all real numbers, but because I shifted, my range goes from 2 to infinity, not including 2. Remember, you read your graph from bottom to top. And so the first point of the first value of y that e to the x plus 2 is getting close to is 2 as it gets further to the left, but then it increases from there. So that's why it goes from 2 to infinity. Okay, so let's move on to another example that I'll make up here. So suppose we want to state the shift of this function, describe the shift of y equals e to the x minus 1 minus 5. Okay, so this is going to represent both a horizontal and vertical shift. So remember, vertical will have to do with a number being added or subtracted from the function itself. So the function is this one, and then we're taking 5 away. So it's a vertical shift down by 5 units. But anything that's affecting the x directly, the way it is in this piece here, we're taking 1 away. And with horizontal shifts, it's kind of the opposite of what you'd think. When you're subtracting, you're actually going right. And so then it's a horizontal shift, 1 unit, horizontal shift right by 1 unit. Okay, so that's it for this lesson. Give the homework a try. Good luck.